Okay, so we're going to go over the questions in the quiz, but before we do, I want to yell at you guys for a second about some common log mistakes that a lot of you are making. So, some of you are saying, well, hey, the logarithm, and it doesn't matter what the base is, so I'll just write it as log base b of whatever number x divided by log base b of y, you can just kind of cancel the log b and you get x over y. Absolutely not. You're not multiplying by log. Log is some complicated function that eats in the variable and spits something out. So, bad calculus student, don't do that. Okay, also, a more subtle mistake you guys are making is you might have something like e to the ln of x times y. So you'll have ln of one thing times some other number completely that's not inside of the logarithm, and you'll just kind of cancel the e with the ln, and you imagine that somehow the x comes out as times y. That's not the way it works. Sorry, that doesn't work. Let's actually figure out what this would look like. E to the ln of x times y. Now there's a property of logarithms, and I'm using ln, but it doesn't matter what base I'm using, where if you have a constant out front, and the y's outside, so you can move it out front, it doesn't matter, of the logarithm of x, that's the same as log of x. You can bring the y in as an exponent of the thing inside the logarithm, log of x to y. So that when you take, if this is log base b, when you take b to the power of that overall thing, then it would cancel, because you're taking the log of everything in the exponent. And then when it cancels, it would just give you x to the y. So what I have written here is not x times y, but it is x to the y power. That's absolutely true. Another thing, and this one's perhaps even more egregious than the previous mistakes, you say that log base b of x minus y is log base b of x minus log base b of y. No, I don't know what else to say about that. It is absolutely not true. Logarithm doesn't break up over subtraction in that way, and it also doesn't break up in the same way with addition. You can't just say, not every function in the world obeys f of x plus y equals f of x plus f of y. In fact, very few functions do obey that in any context. And then somewhat more forgiving, but still a horrible mistake that you absolutely shouldn't make, is that log base b of x minus y is equal to log base b of x over log base b of y. Or if you want to do it with the addition version of it, log base b of x plus y equals log base b of x times log base b of y. And it doesn't matter. All of these things work for any base b, whether it's base e. Remember, log base e, where e is Euler's number, is what we call ln. But it doesn't matter. All these properties are obeyed, except for these are wrong. You're remembering the properties incorrectly. This would work if we were dealing with exponents. B to the x minus y equals b to the x over b to the y. It takes subtraction inside the function and it turns it to the quotient outside the function. Or over here it takes addition inside and it turns it into multiplication outside. Okay, so these properties, you're thinking of the exponential properties. The logarithm properties work in exactly the opposite way. Log base b of x divided by y. So the quotient is on the inside of the function. That is what's equal to log base b of x minus log base b of y. It converts division inside into subtraction outside the function. And similarly, log base b of x times y, multiplication inside the function, turns into addition outside the function. Log base b of x plus log base b of y. And before I move on to the problems, let me just make one more remark. For any b, and I guess maybe I should throw out 0, b to the 0th power is, you guys should all know this, it's equal to 1. Okay, that's going to matter right now in just a moment. Okay, so let's actually answer the questions we were supposed to answer for the quiz. You were given something ugly like log base 2 of the square root of 3 minus the square root of 2 plus log base 2, so it wasn't ugly enough, radical 3 plus that of 2, and they want you to evaluate it. They want you to simplify it. So looking at the correct properties, you would have said, when I add two logarithms on the outside, I can combine into a single logarithm where I take the product of the two things on the inside. So you could have said, well, that's equal to log base 2, again, the base doesn't matter, of this product, radical 3 minus radical 2, remember the parentheses so you don't make a mistake, radical 3 plus radical 2 on the inside. And then you would have just FOILed that out and seen what it comes out to. Root 3 times root 3 is 3. You have a negative root 2 times root 3. So I'll just write it as minus root 2 root 3. No need to simplify right now because the very next term, the outer terms, are root 3 times positive root 2. So that's plus root 3 times root 2. And then finally, minus root 2 times positive root 2 is a minus root 2 squared is 2. So you'll notice that these middle terms here cancel anyway, because you have negative radical 6 plus radical 6. So it's just log base 2 of 3 minus 2, which of course is log base 2 of 1. And so let's remember this important property, b to the 0 equals 1. What is log base b of a number, of the number 1? Well, that is by definition, what do you have to take b to get to 1? And I just told you that. You take b to the 0 to get to 1. So that means that this is 0. And this is true for any base b that we consider. So this is another property. In the same way that b to the 0 equals 1, and you should always remember that, you should always remember that log base b, whatever value b has, of 1 equals 0. These two, they imply each other. These are equivalent statements. So log base 2 of 1, heck, we don't need to even care about the fact that there's a 2 there. No matter what that is there, that's always going to be 0. So actually, he said log base 2 on the quiz, but it could have been log base anything at all, and we would have gotten the same answer. You would have eaten it in, it would have turned into log base something of 1, and you would have gotten 0 as a result of that. Now on the next problem, we're asked for a more interesting thing. Log base, and now the base is really weird looking. It's radical 2 plus 1. And we're taking the logarithm of radical 2 minus 1. And we're given a very suggestive hint where we're asked to find, well, what is the multiplicative inverse of radical 2 minus 1? What does multiplicative inverse mean? It means, what do you multiply radical 2 minus 1 by to get to 1? That's what multiplicative inverse means. Okay? And so, well, what do you multiply it by? Well, okay, you multiply it by 1 divided by whatever it is, right? The multiplicative inverse of b is just 1 over b, because that's what you have to multiply it by to get to 1. So 1 over root 2 minus 1. Okay, but how do you rationalize the denominator? To simplify this out, and that's the key here, to rationalize the denominator, you would multiply by, you guys remember how to do it? You multiply by the square root of 2 plus 1 over the square root of 2 plus 1. And that's something you might have been able to figure out just by kind of the fact that that's what they give you. So you multiply this out, and what do you get? I'm sorry, yeah, you multiply this out, and what do you get? I'm sorry. All right, forget what I just said. We don't need to rationalize the denominator or write it this way. So the point is this. They're suggesting to you that this is going to be the multiplicative inverse of this. Try it out. So you just multiply them out. Radical 2 minus 1 times radical 2 plus 1. And when you FOIL it out, what you'll get is 2 minus root 2 plus root 2 minus 1. This negative root 2 cancels with this positive root 2. This is just 2 minus 1, which is just 1. So the point is that if you multiply this guy by this guy, you get 1. This is the multiplicative inverse. Alright, so now that we have this equation, that this is equal to 1, I'll write it here. This equals 1. Now what can we do? I'm tired of green. I'm switching to black. Okay, what we can do now is say, well, that means that root 2 minus 1 is just dividing both sides by this term, 1 over the square root of 2 plus 1. That's what the square root of 2 minus 1 is, because when you multiply them, you get 1. That's what we just figured out. Or if you like, you can write that as the square root of 2 plus 1 to the negative first power, because that's what it means to take to the negative first power. Okay, so now that we've written this guy in terms of this quantity, which was the base of our logarithm, let's try and calculate that logarithm again. Log base root 2 plus 1 of, now we can write it as root 2 plus 1 to the negative 1 power. But what happens, what's the property of logarithms? They cancel. Look, we have the base, we have something of the form log base b of b to the negative 1. Well, obviously, the log base b cancels with the exponentiation of b, and you just get negative 1. So we get a negative 1 here. Okay, so that's the answer there. And it is similar to the kind of problem that we had here when you realize, oh, wait a minute, this is the multiplicative inverse of that, right? When we multiplied them out, we did get 1 itself. So that's what these two problems had in common.